Alright, in this video we want to learn how to find the values of inverse trig functions. And there's two things I want to mention before we actually do these problems. Number one is what kind of answers should you even get out of a trig function. That's important to understand. So here's what I mean by that. If I asked you what is the sine of 30 degrees, okay, and I'll tell you how to memorize these in just a sec. If you put that in a calculator, you would get 1/2 as your answer. What inverse functions mean, inverse, first of all, the symbol would be sine with that little -1, or inverse cosine, inverse tangent. You can see those on number 1 and 2. Here's what this translates to mean. This means tell me what angle, okay, what angle has a sine of, and then whatever we put in here. So let's put in 1/2. So in this case, what this means, what sine -1 of half means is what angle has a sine of 1/2. So here's the important thing to understand. When you're doing sine, you plug an angle into your sine. When you're doing inverse sine, you're going to get an angle out as your answer. So if the sine of 30 degrees is 1/2, that means the inverse sine of 1/2 would be 30 degrees. What angle has a sine of 1/2? 30 degrees does. So that's what we mean by inverse trig functions. Remember, inverses mean opposites. You're kind of switching the x and the y. So in this table right here, I always recommend that people memorize sine and cosine for the following three angles, because these are the three most important angles in trig, and that would be 30 degrees, 45 degrees, and 60 degrees. And if you're doing those in radians, it would be pi over 6, pi over 4, and this one is pi over 3. Alright, so here's how you memorize it. Everything in this table is going to be square root of something over 2, or everything in the sine and cosine. Tangent's a little bit different. Okay, so everything here is square root of something over 2. And then here's how you remember it. The cosines count up, so they go 1, 2, and 3. The sines count up, the cosines count down, 3, and 2, and 1. Okay, so the sine of 30 is square root of 1 is just 1, so 1 over 2. Sine of 45, root 2 over 2. Sine of 60, root 3 over 2. The cosines are the exact opposite. Tangent is the same as sine divided by cosine. So to get the tangent, all you have to do is just divide these. So for example, 45, root 2 over 2 divided by itself just equals 1. This top one right here turns out to be, when you divide it, it's 1 over root 3. And if you multiply the top and the bottom by root 3, you would get that, and then 60, tangent of 60 is root 3. So that's a very good table to have memorized, because we can now use that to find the answers to number 1 and 2. So our two steps in doing this: first we find the reference angle. That means what angle has this cosine right here, and we have to pay attention to the negative. So the cosine of some angle is root 3 over 2. If we look at our table, we can see that the one that has root 3 over 2 is 30 degrees. So this is going to be something with 30 degrees. That's the reference angle. Okay, why do I say it's the reference angle instead of the exact angle? Here's why. If you go to your axis right here, remember this acronym stands for All Students Take Calculus, ASTC. Stands for All Students Take Calculus. So we have an angle that's giving us a negative cosine. So that means we can't actually be at 30 degrees, because in the 30 degree quadrant, 30 degrees is right here. All of them are positive, including cosine. So there are three other places besides the first quadrant that have a reference angle of 30 degrees, and we just have to figure out which ones will apply to us. Okay, so the inverse cosine of negative root 3 over 2, it's going to be, well, where is cosine negative? Cosine is negative here, because sine is positive there. That's also negative here. Okay, and it's going to be this second quadrant one, and the reason why we said in a prior video, the range of cosine, or cosine goes through its entire range. Remember, cosine is the x-coordinate. On the unit circle, cosine goes through its entire range as a maximum of x equals 1 and a minimum over here of x equals -1. That whole thing happens between 0 degrees and 180. So we don't actually need to go into these quadrants down here, because we've already covered everything that cosine can cover in those first two quadrants. So this large blue angle right here that I'm tracing, the blue angle that has a reference of 30, would be whatever's left over after I take 30 away from this half circle from 180. So that's 150 degrees, because 150 plus that 30 right there gives us 180. So the angle right here that we should be getting is 150 degrees. Let's test that on the calculator just to be sure that we have it correct. So if we go to our calculator, we're going to hit second cosine, that's inverse cosine, and then it was negative square root of 3, so second square root 3. And then I need to hit the arrow to come out. You can see it's blinking right now. I need to come out of that, so I'm out of the square root. Now I'm not dividing by 2, still underneath the square root. Okay, and then press equals, and we do get, just move the screen so you can see it, we do get 150 degrees. Okay, so remember there's actually two places where inverse cosine is negative root 302. The other one would be, if you look at this quadrant right here, the other one would be this angle that I'll trace right now in orange. So it's this angle right here, the one in the third quadrant, and that angle will be 180 plus that 30, which would be 210. But that the calculator is not going to give that to us, so I just want to prove that to you. We should, when we do this, we should get, if we do the cosine of 210 degrees, let's make sure we're in degree mode, which we are. Otherwise, it's not going to work. So if we do the cosine of 210 degrees, we should also get negative root 3 over 2, and it's going to give it to us as a decimal. So cosine of 210 is that number, this number, negative 0.86. If you do square root of 3 divided by 2, which we'll do right now, you'll see that this does actually equal that 0.866 number. Okay, so this is just to prove that the calculator is only going to give us one of those places, not both of them. All right, see if you can pause the video and try to do the tangent one as well. Okay. So they're asking us, I'm just going to erase this so we can see it a little bit better. They're asking us for what angle has a tangent of root 3, and it's this angle right here, which I erased, but it was 60 degrees. So we know the reference angle is going to be 60 degrees. Now we have to figure out which quadrant that's going to put us in. So all students take calculus. Tangent is negative right here, and tangent is negative in these quadrants. It's negative in that quadrant because only sine is positive there. That's what S means. And it's also negative in that quadrant. So it means we're going to have a reference angle of 60 and also 60 here. And the question is, which quadrant gives us inverse tangent? What's the domain of inverse tangent? And the answer is you can plug in anything to inverse tangent from negative 90 to positive 90, because tangent goes through its whole range of values from up here at 90, okay, where it's a vertical slope, and then the slope keeps, if you trace all these lines, it keeps going like that, and then down here it's back to undefined, and that's negative 90. So that actually has the same domain as sine does, from pi over 2 or 90 to negative pi over 2 or negative 90. So the point is that when we put this in a calculator, you don't need to in this case because we know it's going to be 60, but you have to keep in mind there's another angle over here that would also have the same tangent of negative root 3. Okay, so we're only concerned with sorry, this graph is getting kind of messy, so let me clear this off. We're only concerned with the one in the fourth quadrant, so let's get that one, okay, because that's where negative 90 is. So we have a reference angle of 60 right here. So the question is, what angle is this, basically, this big red angle? And that's almost all the way, that's almost 360, except for that last 60. So that's going to be 300 degrees. Okay, our exact value should be 300 degrees, or if you did it in terms of radians, that would be 11 pi. Sorry, not 11 pi over 6. It would be 5 pi over 3, which is 10 pi over 6. So let's verify that. Let's do the inverse tan of negative square root of 3, and we should get 300 degrees. Or if you're in radians, you'll get the radian equivalent of that. So we'll close that parentheses. Just got to make sure again that we come out of the square root, close the parentheses, equals, and we get negative 60, and negative 60 is the same as positive 300. So that's how we find exact values of the inverse trig functions.